Hi, in this video, we are going to see how we can build an anomaly detection model using isolation forest. Now, before getting into the model, let's understand different types of anomalies in a data. So there are namely three types of anomalies in a data. It can be an global anomaly or a point anomaly. It can be a contextual anomaly or it can be a collective anomaly. Now, what we are going to see in this video is more how we can identify contextual anomalies, because contextual anomalies are difficult to identify, and we are going to see how we can identify using isolation forest. So before getting that, let's understand what are the different anomalies. We'll be mostly focusing on contextual and global anomaly. Now, if you take this particular graph, and this is like basically your data distribution that is there. Now, if a data point is a global anomaly, then its value is completely outside the distribution of the data set. So in this case, if you see, like, this is how the data set looks like, and if there's a point completely on the top over here where my arrow is, that is basically a global anomaly or a point anomaly. And these are easy to identify, where you can just check your data distribution and you can find out whether the data is 2 standard deviation or 3 standard deviation or 4 standard deviation, whatever it is, whatever that is applicable to your business. A global anomaly is easy to identify. Now, a contextual anomaly in this case is a data point, basically, in this case, is considered to be a contextual anomaly if its value significantly deviates from the rest in some context, right? So if you say the over here, in this data, the temperature from March, it goes up and again comes down during the December period, and again, like, it starts to rise around March, and this is a quarterly data, the graph that you are seeing. And you can see basically there is some like pattern to it, but suddenly over here you can see in December it starts to rise and around June it falls. But over time, if you see the June, there's a peak here, also June there's a peak, and here there is a downturn in June. And maybe something happened. I think it can be other business domain as well. Now suddenly there is an hurricane and all your retail sales have completely come down because the stores are closed, or there's a snowstorm and basically all the taxis are closed at that time. So basically your normal pattern deviates in these cases. So a contextual anomaly is basically anomalies that deviates in a particular context, and you can see this point is over here, it's a contextual anomaly. And in this case, what you are seeing is the data is within the normal range, but it's abnormal compared to its seasonal pattern, right? So now you can see some seasonality in the data over time, and this is abnormal compared to its previous seasonal pattern. Now, when you take an isolation forest model, it does not take time into consideration. It's a pretty much like an tree-based model, and not like a ARIMA or Prophet model, which has a time element to it, where the time lags are being checked. It is a pretty much like a non-time series model. You can just assume for now, right? In order to feed context into an isolation forest on the time element, that's where you do some feature engineering and add it as features to isolation forest. Now, if the data is not like very high dimensional, you can also use Harimax or Prophet model. But when the data is very high dimensional, as multiple attributes and time element to it, typically you want to go with isolation forest, because it's easy to feature engineer and build the model and also interpret the model. So that's what we are going to do now. Now we are going to see how we can use isolation forest to identify this contextual outliers. So let's get started. What I'm doing is I am importing a set of libraries over here. I have matplotlib and plotly x plus for visualization. I have pandas just to read the data, and numpy to process the data, and then I'm using from scikit-learn ensemble isolation forest, which is going to be our modeling algorithm, right? Let me quickly run this, and the data that I'm going to use is in the nab repository, numanta nab. You can go to this GitHub repository and download the data set, and I'm going to use the nyc taxi data set. So let's first see the data set over here quickly. Now this data set is basically the number of trips that the New York taxi makes, and the data is there from 2014 July till 2014 January. And you can see the value is the number of rides at a particular time. The data set is every 30 minutes. So from at 00 there were 10,844 rides. At 0:30 between these time there were 8127 rides. So every 30 minutes they capture number of rides the New York City taxi makes. That's what this data set about. Very simple. It has only two columns for now. Right. So let me quickly check the info of the data set, and you can see that two columns, both are one is object and another is integer. Now this is a timed column. This is a time data type. It shows object, and if we want to do some analysis on time, we want to convert that into timestamp so that we can slice and dice by date. Right. So what I'm doing is I'm just taking this particular column timestamp and I am converting it to two date time. So the object over here is getting converted into an timestamp data type. That's what I'm doing. Now, if I run this, you can see basically the first column over here is a date time column, timestamp column. The second one is an integer column. Let me quickly check the output. It's going to be the same, whatever it is. So now the data is every 30 minutes. In order for me to just quickly better visualize and analyze it, what I'm going to do is I'm going to convert this into an hourly data set. Rather than having every 30 minutes, I'm just going to aggregate the two data point and basically take a mean of this value so that I get an hourly level data set rather 30 minutes. So I'm reducing my number of data points by half. That's what I'm trying to do over here. So to do that, I am basically what I'm doing is I'm using the resample function and I'm telling resample to hourly. So it will take the 30 minutes data and then resample to hourly. So I will have every hour of data and I'm taking a mean of the value in this case. That's what I'm doing, and I'm assigning back to the data frame. Now, if you see the data frame over here, I am having data at an hourly level rather than 30 minutes level. So I have at midnight, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. So I have data every hour. Right. Let me quickly visualize the data. So to visualize the data, I'm using Plotly Express. What I'm doing is I'm passing the data frame. Plotly Express, basically I'm removing if there's any date index created. That's what I'm doing. I'm telling my x value is timestamp, my x-axis is timestamp, and y-axis is y value. And then I'm just creating a range slider. Range slider is basically I can slice and dice or zoom into the data to a particular time frame. That's what I'm doing over here. So this will create a range slider visible true. And you can see in the graph, the range slider is below over here. Right now, this is how the data set looks like. So you can see basically from July 2014 till January 2015, the data set is. Let me zoom in and use a small subset of data set to see how the data looks like. Now, if you see over here, the data is there from September 1st to September 6th. And you can see basically every day there is some pattern to it. There's some pattern that's up and down. So there is seems to be some daily seasonality, and as well as we need to see whether there is any other seasonality, weekly seasonality or monthly seasonality, right? So that's what we are going to check now. We are going to see whether there is a daily seasonality. As if you look at the graph, there seems to be some daily seasonality. Initially the rides are low, then it becomes high, then again the rides fall down, again the next day same thing, the rides are high, then the rides fall down, rides are high, rides fall down. But there are also some peaks over here compared to the previous day. Right, so let's go and do an analysis if there is any seasonality first, because now, as I told you, right, isolation for us does not understand any time element, and we have to feed the time element. If we take an ARIMA model or if you take a profit model, we can actually feed in whether there's a weekly seasonality or monthly seasonality or whatever seasonality, and it will create a auto correlation between the previous lags, and it will build the model for us, right? But here we have to do it by ourselves. Right now, what I'm doing, the first thing, since there's hourly seasonality, I am basically adding a new column called df hour, and from the timestamp I am extracting only the hour. That is, so basically it will take the hour column from the timestamp column that we have and assign it to a new column in the data frame called hour. I am also doing a weekday. I am also extracting the weekday over here. So basically, I want to know whether it's a Sunday, Monday, Tuesday, Wednesday, Thursday. The reason is, if you take typically a taxis, right? The taxis may run pretty high on a weekday compared to a weekend, because a lot of people might take it to go to office and everything. And typically, New York City, if you know, is a business hub. So based on my understanding of New York City, I am just going to create also one more column called weekday. And to do that, what I'm doing is I'm taking from the date, I am just taking the weekday, and I am converting it to categorical data and telling that the first zero is one, zero is Monday, one is Tuesday, two is Wednesday, Thursday. So basically, it's going to give me the weekday column over here. If I quickly run the info on the data set, you can see I have a timestamp column, I have a float column, I have a integer column which is an hour, and then I have a category value. Now the integer value on top became float. The reason is we took a mean over there, and that's why it is. And then I have a category column. Let me quickly print the data frame output so that you can see how it looks like. Now you can see this is basically 0 hour. That is 00:00. This is the first hour 01. So it's extracting hour column and putting it to hour. And this basically it's telling it's a Tuesday or Wednesday or Thursday or whatever it is, right? Now this I have done. What I'm going to do is I'm going to now go and plot and check whether there is any seasonality to it. So for that, what I'm doing is I'm taking the value column that is on the top, and then I am grouping it by hour and taking a mean and creating a plot over here. So every hour I am seeing how many rides are happening on an average, right, across the data set. So if you see over here, now the midnight to morning 5 o'clock, the rides fall drastically. Typically, not many people use rides during the night time, right? And as 5 o'clock, you can see the number of rides are constantly increasing. And then again on the evening time, it's even more increasing. So people take a lot of rides for office commute. So they, from starting from morning 5 o'clock, you can see they use a lot of taxis. And then again at evening time, while coming back from the office, they use a lot of rides. It goes up till around like say 7 o'clock or 8 o'clock, and then again it falls down during the night time. So that seems to be a daily seasonality over here. Now let me also check if there is a weekday seasonality. So to do that, what I am doing is I am taking, instead of hour, I am taking a weekday, and then I am creating a mean and I am plotting it, right? See, the reason I am doing this is if there is any seasonality, I need to pass it as a feature to my isolation forest so that it can understand the context to identify the contextual outliers, right? Now, Saturdays, the average volume of rides may be less. So if you see any previous Saturday, suddenly there's a spike in volume, it can understand this data is out of context. It may not be a global outlier, but it is out of context, right? That's what we are trying to see. And I will show you how the data looks like and what are the contextual outliers and all. So now if you see over here, this is how the weekday plot looks like. And you can see usually Monday, Tuesday, Wednesday, Thursday, the rides are higher. But on Saturday and Sunday, it falls down and comes to almost like pretty low. And again, Monday, it picks up, right? Monday, Tuesday, Wednesday. So there's a weekday, the rides are higher compared to the weekends. So we know there's a weekday seasonality as well. There's a weekly seasonality as well over here. Now, what I'm going to do is I'm going to visualize both the hour and weekday together. That's what I'm doing, the third plot. In this plot, what I'm doing is I'm grouped by hour and weekday. I am taking a mean of it and I am unstacking it. So what it's going to do is it's going to create separate plots for each weekday, the unstack function. So here if you see, I have my hour on the x-axis, the number of value rides on the y-axis, and then weekday each day as a separate plot now. And you can see over here, there is a seasonality as we saw previously on day, every day there's a seasonality. On Saturday and Sunday, if you see this pattern, on normal days, the night volume is pretty less, but on Saturday and Sunday, it's pretty higher. But overall, we know Saturday and Sunday has less volume, but the night volume on Saturday, Sunday is pretty higher. And reason is New York City is basically a tourist spot as well. That is Times Square, Rockefeller Center, Empire State. It's kind of a night city. A lot of people go there on a weekend to basically roam around or go to the Broadway shows and everything, right? So that's why you can see on Saturday the night volume is pretty higher compared to the day volume, right? And that is a seasonality as well, as we saw earlier, right? So now what I'm going to do is, now we know exactly there's a weekday seasonality and there is also a hourly seasonality. So what I'm going to do is I'm going to create one more column and add it to a data frame. I am not going to use this column in the model, but I'm just creating so that I can see like how does an average ride look like on a particular day and a particular weekday, on a particular hour and a particular weekday. So for that, what I'm doing is I'm using this group by hour and weekday, whatever we did on the top, I'm taking a mean, and then so this will give me a mean per hour on a weekday. So at 1 o'clock Tuesday, what is the mean value? On 2 o'clock Wednesday, what is the mean value? Something it will give me and mean value for both hour and weekday. And then I am just printing it so that you can see how the data frame looks like now. So in this case, if you see, this is the value at 0 hour and Tuesday. It's 9485. The average value is 8483. Here it's 5433. It's 5028. So these are pretty close, right? Now again, this column I'm not going to use it doing modeling. I'm just using it so that I can see visually how my data points are separate during that day, right? So now what I'm going to do is I just visualized it, I have not assigned to the data frame. Now I'm going to assign it to the data frame as well. I'm creating one more data frame and taking the actual data frame and joining with this group by and assigning to a df underscore final data frame. So if you see the output df underscore final, you can see basically that column is also added, and this is only for analysis purpose. I'm not going to use it in the model. Now based on the data set that we have in the Numanta NAB repository where I picked it, you can see these are the different anomalous point that they have mentioned. On basically 2nd November 2014, there was a New York Marathon. So basically the number of rides were pretty higher on that day. On 27/11/2014, there was Thanksgiving, and then there's a Christmas and the New Year. Definitely, if you see basically New Year, the night time, a lot of people go to Times Square. So you can see midnight, the volume goes pretty high, or after midnight when people return back home. And on 26th and 27th January 2015, there was a snow blizzard. And when there is snow, blizzard or there's a snowstorm, not a lot of taxis really go and drive. They typically stay home. Even people stay home to avoid the snowstorm. So these are the different anomalous points. Now let's see whether our model that we are going to build is capture all of this or capture at least some of this, right? So let's also visualize the output, how it looks like. Now one is 2nd November and second is 26th and 27th January. So what I'm doing is from this particular data frame, I am just locating the 0 to 11 2014 data where there's an anomalous point. So let me quickly run this. And then you can see over here, this is how the 2nd November data looks like, right? Now if you quickly scroll down, you can see over here the average ride on 0 hour is 23,000 and it is 24,000. On 0th hour it was fine, but on 1 o'clock it is average is 21,000 but it was 37,000. So this looks like it was pretty high during 1 o'clock at the night. And subsequently, if you see it's 17,000, it's 12,000, 13,000, 8,000, it fell. But only at 1 o'clock, the rides were significantly higher compared to this, right? So that's why I took the average just to show this. In this case, 37,000 may be a global outlier as well, right? But now let's go to a different point and see whether it's a global outlier or it's a contextual outlier. And in this case, it's a contextual outlier if you really see, because there was some event that triggered it on that day, right? Now, in this case, what I'm doing is I'm taking 26th and 27th data where there was a snow blizzard. So let me quickly run this. And in this case, if you see 26th and 27th on snow blizzard, so let me quickly, if you see over here, 14,000 is the average, right? But at that day, only 5,800 were there. And if you come down, 12,000 is the average rate, but only 243 rides happened across New York City. Year 8483, only 94 rides happened. So almost like literally no taxi was running. Very few taxis were out there. Either they were stuck or they were just trying to take the passengers around, right? But literally you can see like how low this particular value had come in during the snow blizzards, right? Now what I'm going to do is I'm going to create in the final data frame, the weekday column that I had was a categorical column. Now I can go and create categorical to numerical indexing. Rather than doing that, I'm adding one more column. I'm just taking the weekday as it is. So it will take the weekday as numerical value and assign it to a day column, right? Now if you see the day final, basically it will just have the day column in the numeric value. I have Tuesday is 1, Saturday is 5, so it has a numerical value as well, because I into the model I cannot field a categorical value, I need a numerical value. Now since I'm using isolation forest, I don't want to one not encode it. You can do it as well, there's nothing wrong, but since isolation forest just works in splitting the tree and distributing it, it will take care. One not encoding is not required. The only thing you have to do is numerical encoding, right? So now I have my final data frame, right? Now what I'm going to do is I'm going to take only the value column, hour column, and day column. The hour column is what hour the ride happened, and the day column is basically the day of the weekday value, and I'm assigned to data because I don't want to take the average value and other things. I'm taking only 3, right? So this will be the data column. Now I'm going to use isolation forest. Now isolation forest is an unsupervised learning algorithm for anomaly detection that works basically on the principle of isolating anomalies instead of profiling the normal data, right? Now typically some algorithm, what you do when you have like normal and abnormal data, it will work more with the normal data, but the way isolation works is it kind of works on profiling the abnormal data. That's what it does, and it's an unsupervised learning algorithm as well. So we don't have any label in this case, right? And that's what we are going to use in this case. Let me run this. There is multiple parameters I have used. You can run a grid search to understand what parameter is the best parameter, but based on my understanding, I am telling like take the max features as 3, and I have only 3 features. The max sample as 0.8, that is take 80% of the sample in the each tree that you build. Since I've given max features 3, it's not necessary it is going to use all the 3 features in all the tree. It can use 2 features or 1 features as well. Isolation forest will use it accordingly. And the number of estimators I want to build for is for 200. Now this contamination level is something, basically what you are telling it simply controls the threshold for your decision function. That's what it does on how many anomalies you want to consider in this case. So what I'm telling my contamination level is like 0.005, that is 5%, 0.5%. So take like 0.5% of the top anomalies and show it to me. That's what it's going to do. You can leave it as well. It will go in an auto mode. I'm just going to use it, but I will show you down how we can take a score and then identify the anomaly threshold. In this case, I just put like 0.5%. I don't want to see too many anomalies over here, right? So if my data is say 100, it's going to take like maybe say like zero point 0.5 data point, right? If it is 200, it's going to take 1 data point and show it as anomaly. So I run this model. Now what I'm going to do is my model is ready. It has fitted for the data. Now what I'm going to do is I'm going to take this model and I am going to predict with the data that I have in this case. And then what I am telling is basically the output of the model.predict will be 1 or -1. -1 is an anomalous point, 1 is a normal point. So I'm telling if it's x equal to -1, in this case I'm telling put it yes, that means it's an anomalous point, else no. That's what it is, and I'm assigning it to an data frame with an column name called outlier in this case. So once I run this, I will just query where the outlier is equal to yes in this case. So it's going to show me that 0.5% data point out of the data set. And you can see like basically it has showed me a lot of data, even though these all may not be outlier. But let's quickly go and check. Now, if you see like the 2nd November was an anomalous point, 27th and 26th was, 1st January was, right? So if you go on the top over here, you can actually see like 2nd November as one anomalous point. Here 21 is the average value and 37 is the actual value that was there. And basically average value I did not use again in the model, right? So this one it was able to find out. Then basically it was able to find out on 25th December. Usually the average ride at that time, at that particular hour and weekday is 20,000. But here it's 77977. And again, I did not do a lot of feature engineering. I just added hour and weekday. Now if the data is very complex and you have multiple time series column, you can take like previous value lags automatically, a rolling window or function and feed it as features, right? But here, in this case, 25th December also it identify that it is an anomaly over here. The rides are very less than the normal. 27th November, it missed it. Sorry, 27th November, yeah, that was one other data point below, but it could not identify 27th November. But it did all other points, like 1st of Jan is here. On 1st of Jan, typically it's 12,000 and 8,000. It is 25,000 and 29,000 rides, right? And even the 2 p.m. and 3 p.m., the rides are pretty higher. So usually it's 5,000 and 3,000, it's 25,000, which is way higher, right? And finally, on 26th and 27th, there was a snow blizzard. And you can see all these points over here, 26th and 27th were identified over here. Now, there are too many anomalies, right? Now, if we go by default with the model.predict, you may get a lot of anomalies. But we want to go and maybe put a threshold by a score and pick only the top 10 anomalies or top 5 anomalies, right? So let's see how to do that from here on. First, let's visualize the output and see like how does the anomaly point looks like. So I'm just printing the final data frame that we got, which is similar to what we saw on the top. And I'm again using an Plotly Express plot. In this case, what I'm doing is I'm telling my x-axis timestamp and y-axis is value, and the color of the particular point, I am feeding the outliers column that I assigned to the df underscore final, which is the yes or no, right? And then I am telling when I over on it, show me the weekday, hour, and value average, so that I can do an analysis further. If I look at the data point, it will show me on point on the data point. It will show me like an hover on it. I'll just show you how it is, and then I'm using a range slider. So once I run this, it's going to show me the graph with the anomalous point. In this case, the anomaly point, the color reds are anomaly over here, and you can see on the on basically your 2nd November, the data 37,000, it's completely a global anomaly as well. So even without feature engineering, it might have identified it. But if you see other points over here, these are all looks like a inlier. It's not like a global anomaly over here. This all looks like a inlier, and it was able to identify those points. So let me go and zoom into a few points, right? Let me go over here and zoom in. In this case, if you see, on Jan 4th, the average is 11,686 and it's 8,000, right? Let's even go over here, and you can see this Jan 1st. Jan 1st is the New Year crowd that comes in, and here if you see, the average is 3683, but the value was 22,000. Now 22,000 is not a global anomaly, it's a contextual anomaly, because our data distribution already has, if you see, 25k and 30k. So it was very difficult for a normal model to identify, and in this case it was able to identify this global anomalies, right? So that's where isolation forest with feature engineering help. And when you have a lot of high dimensional space and lot of time series as features, isolation forest can do a lot better job with proper feature engineering. Feature engineering is the key ingredient over here. Now let's go from just detecting anomaly or not to see where we can draw a boundary so that we can control which anomalies I want to pick, right? So for that, in the model, there's something called a decision function. I can pass the data, and instead of giving just a -1 or 1, it will give me a score in this case. So let me take this score and let me print the score over here. So if you see over here, it's giving me a continuous score over here, right? What I'm going to do is I'm going to take this score and plot it into 50 bins. I'm just drawing a histogram of the score that I got. Okay. Now in this case, if you see over here, what I am doing basically is this is how your histogram looks like. Most of the values are towards the right, but if you see, there are like some values which are to the left as well, and looks like these left values are completely like anomalous points, right? Now I can go and draw a cutoff line over here. So I can do a cutoff either at -0.05 and tell anything less than -0.05 is an anomaly. But I want to control it even further. I can even go on the right hand side a -0.10 as anomaly. So here is where your domain experience, after seeing the output, comes into play, right? So I can put my threshold anywhere I want in this case, and by the score I can filter it out. What I will do is I will assign the score that I generated to my final data frame, called like scores column. So now if you see my final data frame, I have the score column also. Apart from the regular columns, you can see I have my score column also. And what I'm going to do is I'm going to pick a threshold, and I'm going to filter it out and see how the outlier look like. In this case, what I'm doing is I'm taking from the final and querying where score is less than minus 0.02. So in this case, I am basically putting a threshold at 0.02 somewhere over here, somewhere at this space. And I'm going to see like how my outlier list looks like. Earlier there were a lot of outliers, so now maybe we may have less outliers. So if you see, compared to previous time, we have only this many outliers. And in this case, I still got the 2nd November, I got the 25th December, I got 1st of Jan, and on 26th and 27th I got few values, not a lot of values. So this is how you control where you want to put the threshold to identify your outliers, because you don't want some outliers are pretty much common in a typical business scenario. You don't want to highlight all the outliers, you want to only to do a selective outlier. That's where you go and put the threshold based on your domain knowledge. So the idea is basically how we can use isolation forest in this case to basically go and look at both contextual outliers and global outliers. I have a similar video with Facebook Prophet as well, which does it. But Facebook Prophet does it understand the time element. By internally, it works on the auto correlation of your time lags, so it will be able to identify as well. But in high dimension space, this may work faster for you, because you can control how the hyperparameters can be, how your sample split can be, how your tree splits can go. There are a lot of things that you can control in isolation forest. That's about it. Thank you very much.